Hello, my name is Uchechukwu Nwachukwu Ngozi. I'm a master science student in Cardiff Metropolitan University, and this is a project that I'm currently doing. This is detecting human activity. Every day human activities go on, and we use this in so many places. Healthcare, we use it on our phone. The uses is just there's so much. So I'm going to be doing this activity, and I'll be using 3 activities for it. I'll be using drop and pick up, sitting, and shaking. I've collected this data using MATLAB device. So the first thing I do is to call up the tools I'll be using, and these are the tools I'll be using for this project. And the next is to import my file. I've imported the Excel file, and I'll have to check the info contained in the Excel file, after which I'm starting with drop and pick up. I've just called up the tail, check the head, and the next thing I do is to drop the timestamp, because I want to maintain one timestamp for the data frame. So this is it. So this is the code. I've dropped the timestamp for the other sensors. I'm just going to use that of acceleration, the timestamp for acceleration for the data frame. I'm going to repeat this for sitting and also shaking. So when I've done that, I will combine the 3 activities in one master data frame. So here, this is shaking. So I've checked the info of this data, and it's showing that I have 2429 entries, and I don't have any null value for it. So the next thing is to combine the data. So this is it, combining the 3 activities, drop and pick up, shaking, and sitting in one master data frame. So I've done this here. So I'm going to be working with this and prepare it further for the machine learning. So this is exploratory data analysis, doing the visualization. This is a bar chart trying to show the activities that are going on, and this plot here is just showing that there is this is shaking. So shaking seems to be dominating in all the activities. Probably there are more movements that are in it, and going ahead, this is just to reset the index, because there are 2 numbers here, so have to drop one and maintain one, and this is what was done here. The index was dropped. Next thing is data visualization. These are just plots for the acceleration, magnetic field, angular velocity, and the orientation plot. So all these things we are done just to see the activities that are going on visually. But you cannot be able to determine what has happened here. So what you can do is to go ahead and so the next thing is just to go ahead and start the machine learning to view it further. And these are the features that will be used for this. The problem is just to use different data activities, collect the data, evaluate, and then the features, that is acceleration, angular velocity, magnetic field, and the orientation. So the master DF is what we are still working with here, and you just explore more. This heat map was just used to check if there is any null value, and there was no null value. So the techniques that will be employed in this is just to use linear regression. Linear regression, KNN, and random forest is what will be used here. So going ahead, so this is just a plot that is showing the activity column, and there's a dot described. This is a describe.c to see what is going on in it. This is a correlation matrix to quantify It's just to quantify the correlation between the variables, and results show that the data has no strong correlation. So we have to move further and do the machine learning. So now he's building the model, and the first thing you do is to split your data into X and Y. After doing that, you split the data also for your trained data and the test data, so that you can be able to test the data after the model has been built. And the formula of the division I used is 0.2 and 0.8, that is 80% and 20%. 80% to be used to train the data, to train the model, and 0.2 will be used to test the data. And the next is to scale the data. Scaling the data, this is the code that was used. And going ahead, as I mentioned before, these are the three models that will be employed in this: logistic regression, KNN, and random forest. So these are the codes to call it up, and when applied, this gave a score of 1.0 for random forest, KNN of 0.9, and logistic regression of 0.9. It shows that KNN is more effective here, but however, we have to move ahead and compare, and also do tuning for the hyperparameters to be able to determine. So this is creating of the hyperparameters and and this is also the tuning for all the parameters. So going down and then checking the best hyperparameter to see if there will be an improved result. I did that for random search and also for grid search. And coming down to test the data, so to test the data, so this is after tuning of random search, the data was showing a result of 0.991, that's for the model for forest classifier, and 0.99 also for the first tuning. Okay, so generally, after tuning of the random forest classifier, an output result of 0.991 was achieved compared to 0.9979 achieved in the first tuning, and 1 from the first model score. This shows that the tuning of the random forest algorithm did not improve the accuracy score. This had a computational time of 4 minutes because it's high actually. Is that of KNN, that KNN improved and also random forest improved as well. So now he's writing a function to evaluate the final models together. So that we can see if there was an improvement. So this is the final result that was gotten. There's the 0.99, KNN 1.0, random forest 1.0, logistic 0.98. So this shows that KNN and random forest actually improved. So the next thing to do is to go to the confusion matrix. So confusion matrix is just to check the things that fell out and the things that were predicted. So from this now, it was shown that only 3 fell out, and here only 12 and 3, that is 15, fell out from this class, and here only 3 fell out. But for KNN and random forest, nothing fell out. The prediction was perfect and 100%. So this is the classification report, and the feature importance, this is just to be able to see the feature that is contributing more to the activity. And from the graph down here was noticed that is mag-y, that is magnetic field, that contributed more to the this activity recognition. So that is the end of this video. I hope you enjoyed it, and till next time, you take care of yourself. Bye. Before I go, yeah, KNN, so in conclusion, the findings here show that KNN is better than the other models because the running time, that's the computational time for KNN, was lower compared to the other ones, and also to the other ones. So that is it. Thank you, and do stay safe. Bye.